Okay, in this video I'm going to go over how to download and prep DEMs for inputs into VBET, and I'm going to go over a couple methods from a couple different websites, slightly different, but you get to the same end result. So the preferred method that is the easiest way is to get it from the USDA Geospatial Data Gateway. This has been down recently though, but it's back up, so if you are able to do it from here, do it from here. It's easier than downloading through the national map. So once you get to this main screen, you're going to go to Order by Place down in the right hand corner, and you'll select the state of interest. So say we're doing the Lemhi again like we just did for Land to Fire, so go to Idaho, select type of place. The benefit about doing it through the USDA Geospatial Data Gateway is you download all the tiles for a specific hydrologic unit, and then it's going to ask you the name of that place. So this is actually the hydrologic unit code. So I'm going to go back into ARC just to get that download. Bring in my my HUC data set and bring up my network so that I know where I'm at. So I got the Lemhi up. Bring that HUC in. Select that. Open the attribute table. And go over and get my HUC ID. And I'll just paste that here. Select find place, so it's found that HUC. So now it's going to download all the tiles that I need to encompass that entire HUC dataset. So I'll select the place, and then it's asking you what you want to download, and I want elevation, and I want 10 meter. So I'll select that, hit continue. Nice thing is it puts it into the correct UTMs for that. You can see that over here, order projection, auto UTM to quadrangle. So it's already going to be projected, which is nice for another reason I like downloading from the USDA. And then we'll hit continue. It's going to ask for an email. And I'll give you an estimated time of delivery, 8 minutes. I'll place order. So it's actually going to email me the data. So hopefully it goes pretty fast. I know sometimes they're slow, but for the most part it usually comes within a couple minutes. So I'm going to wait for that, and then once I get that email I'll download it. While I'm waiting for that email to come, the other method of downloading the digital elevation data is from the national map. I'm going to go to this version 1. I prefer it to version 2. It's a little less glitchy. Anyways, I will zoom to the watershed. And I just need to have the whole watershed within view. So I've got the bottom end of the watershed here, and I've got the top all within view. So once I've done that, I'll go over here to the elevation products, and I'm after 1/3 arc second, which is equivalent to a 10 meter DEM. And arc grid's fine. So I will hit find products. So now what it does is it gives you all the individual tiles for that area, and if you hit footprint you can see which ones you're actually downloading. And so as you can see, it will give you all the tiles within the view extent. So I'm going to download. It appears as if these 2 tiles cover my whole watershed. I might need to download this one too, but for now I'll just download this one and this one. And those should open here in just a minute. So I'm going to extract that to wherever you want it saved. Extract. And that was this one. So then I'll extract this one. I'm going to save it to the same place. It's going to say that there's some files with the same name. This is just metadata stuff. So I'm just going to replace the files. I'll still have the tiles I need because those are named differently, but I don't really care about the metadata stuff that's in here. So I'm just going to replace these files. You can skip them too if you want, but either way. So download those. We'll go back into Arc. Make sure we have everything we need downloaded. So here's those tiles. Each one has a the raster dataset, and this one that looks like a raster dataset is a thumbnail. So just like a picture of that actual area. We don't need that. So we're after these 2. We'll pull that one in. Okay, so that has loaded in. So it looks like we just need the 2 tiles. This area is all fully covered, so I'll bring in that other one now. Okay, so I have both my DEM tiles I need here, and as you can see, so these are the ones that I downloaded from the National Map Viewer. And one of the reasons this is my second, if I can't get it from USDA, I'll download it here, but from USDA is nicer, because if you come into the properties and actually look at it, it's not projected. It's just in a geographic coordinate system, so it has no spatial reference. So you have to make sure when you do the next step that you actually give it a projection. But we'll go ahead and see if the other data downloaded to my email yet. Okay, so I'm still waiting on that email from the Geospatial Data Gateway, but the process is basically the same, so we'll go over what the next step is, whether you download it from USDA or from the national map. So once you have your rasters, your digital elevation rasters, and you can verify that it's going to include your entire watershed, you're going to use a tool called Mosaic to New Raster. And what this will do is it will combine these 2 tiles into one raster dataset. So that if they're both on the map, I'll just select these. And I'm going to save an output location. I'm just going to save it to the same place that the inputs are at. Call it Lemhi DEM. Oh, it's asking for the folder, so I'll just specify the folder. And then here's where I would name it. Lemhi DEM. It's always nice to put the resolution. So spatial reference, we have to specify a spatial reference here because, as I just checked a minute ago, it's only in a geographic coordinate system, as it says it's optional. So don't forget to put it in, because if you don't, it's just going to keep it in a geographic coordinate system and it's not going to have any units to know where it's actually at. So for Idaho, projected, we use UTM. It's NAD 1983, and we're in zone 11 north. And another important part here is to make sure you change this to 32-bit float, and that basically specifies what the range of values can be here. So if you don't select 32-bit float, your values are going to be way off. You don't need to worry about cell size, that will just transfer through. Number of bands for a DM is 1. And this stuff you can leave the same. Important last step though is to go into environments and go to raster storage. Scroll down to resample here and change this to cubic. If you don't do this and you try and make a hillshade from this DM, it's not going to build the hillshade correctly. And then we'll hit OK. Okay, so that tool finished running. You can see the output right here. I'll turn off these other cells, or these other grids, and as you can see, so now we have one DEM. Both those are merged into one. If I go into the properties, check the source, we got 32-bit floating point, and we are now in projected UTM zone 11. So this is good to continue as an input. The last step we need to do is clip it like we do with all our other inputs. So I already have the hookup and I have it selected. Same thing as with EVT and BPS. I'm just going to do clip data management, input that raster, specify the clipping feature, make sure this is selected, and then I'll simply choose where I'm storing it and what I'm going to call it. So at this point you can either name it by the standard naming protocol that we're using for the input to VBET. So in this case it would be NED DEM 10 meter and then the HUC ID. Or you can just, I could name it Lemhi DEM 10 meter, as long as you're changing that name once you use it as an input in the VBET project builder. So I'm just gonna, for now, I'm gonna name it Lemhi DEM. But if you do that, like I said, just make sure once you pull it into the project builder that you rename it once it's in the project structure. Oh, and I can't name it that because I already have it named as the input, so I'll just we'll add a final on the end here. Okay, so that has finished. There's my output there. I'll turn this one off and turn the hook off. So now we have a DEM clipped to our boundary. It's projected. It's ready to be used as an input in the VBET project builder. And always make sure you clip it before, so that when you run it through VBET and it creates a drainage area, that drainage area will be clipped to the extent of the DEM. Where if we input this into the VBET project, it'll make a drainage area for this whole thing, and you can't clip it later because that will screw up the values. So that's why we always clip it to the boundary first before we use it as an input into any of the tools. So it looks like my email from the data gateway came through. So this is what the email will look like. Down here it will have your ordered items. I'm going to download that zip folder. And it may take a little while to download, but once that's open, I'll show you what that folder is going to look like and how it differs from downloading from the National Map Viewer. Okay, so that data from the USDA is finished downloading. So I'm going to extract that. I'm just going to put it in that same area, and we can look at the differences between the two different ways we downloaded the elevation. And where you choose to download, I guess, is based off preference. It's the same data set, but one, you have to make sure you remember to project it, and you have to download each tile individually, so you have to make sure you download all the tiles that you need. Whereas this one, it projects it and it downloads all the tiles you need, so you don't even need to check. I mean, this one did end up taking longer to download, but so I'll refresh this folder. So here's the one from the USDA Data Gateway, and here was the one I downloaded from the national map. So if I go into this folder, it gives me all these tiles. I'll just pull in one for example. So I downloaded all these tiles, all the ones that I need to make a mosaic of this watershed. And I'll pull that back in, show you. So if I go in here and go into the attributes, it's projected in the proper projection. So this process is the same. I'll just do mosaic to new raster. Clicked on the wrong thing. So input rasters, rather than pulling them into the map, you can just navigate to that folder. Oops, wrong one. Is in here and just select them all. So it's added all those tiles. We'll specify an output location. We'll put it in here, and maybe just so you can see the difference, call it USDA Lemhi 10 meter. Once again, it's just asking for the folder. Spatial reference, we don't need it, it already has it. So there's one of the differences between where you download. You still need to make sure you change this to the 32-bit float, number of bands 1, and you still need to go to raster storage and change the sampling to cubic. And then I'll hit OK. It's gonna run the tool. Alright, so that tool finished running. So if I go to the properties of this new raster, everything looks good. 32-bit float, it's projected. Maybe we can compare it to the old one, or the one from the other source. So they're different extents, but I mean, as you can see where the transition zone is, they're the same raster. They're the same data set. So you would do the same process that I did for the other one, where you just clip the DEM to the boundary. So it's just two different ways to get the same data set from a different source. It's based on preference. You just got to make sure that everything's clipped to the boundary and it's projected. Those are the two most important things, and that it covers the entire boundary. So, and that is it to downloading and preparing a DEM for the VBET input.